this is a particular project which is under consideration, and we are supposed to perform the project crashing based upon some information that are provided. So for instance, in this particular project, we have about 8 activities ranging from E till H. And each of these activities of project have some predecessor successor relation. So the first one, activity A of a project, that has no predecessor. Similarly, for activity B, there are no predecessor. So this particularly means that if we are considering, and we discussed that in one of your lectures, what is a on A network diagram, which is activity on arc. So this means activity A and B originates from the same node 1. So node 1 to node 2, consider that activity A, and node 1 to 3, that considered activity B. So there are no predecessors for that. Both of these activities are starting from the same node. So we don't have any predecessor. Similarly, activity C can only start when A is completed. Activity D can only start when B is completed, and so on and so forth. For activity G and H, there are 2 predecessors. So G can only start when D and F are completed, D and E are completed, and H can only start when F and G is completed. And we talked about that particular relation between the predecessor and successor and how to translate that into a particular network diagram, which the one which we consider was activity on arc. However, this video tutorial will summarize the activity of linear programming and how is it relevant to project crashing. So now there are terms like normal duration or normal time, crash time, normal cost, and crash cost. We talked about that in your lecture. So in order to start with this particular algorithm, we are supposed to create a new cell, and let's call that cell as a crash limit. So what is crash limit? Crash limit is simply the limit by which you can crash a particular activity. So how can we estimate that? It's really simple. All you need to do is subtract the crash time from the normal time. So in this case, I'm supposed to subtract this cell from that cell right there. So I'm going to subtract cell E4 from cell F4. So the crash limit for the first activity is about 1 week. We can crash it till max of 1 week. So since the durations are represented right here in weeks and the costs are represented in dollars, right? So if we drag it down, so that would give us different crash limit for different, some of them are similar, some are different for these different activities from E to H. This means that in case of A, the crash limit is about 1 week. In case of activity B, the crash limit is 2, and so on and so forth. For activity G, the crash limit is 3. So this means in this particular activity G can be crashed about 3 weeks, having a normal duration of 5 weeks. So after estimating the crash limit, we're supposed to come up with a new column, and let's call that a column of slope. Now, what is a slope? You can call slope as slope is defined basically by this equation. So slope in this regard is equal to the crash cost minus normal cost divided by normal time minus crash time. And we discussed that thing in detail. Why do we call it slope? Slope, we call it in a sense that if we crash a particular activity 1 period at a time, what additional cost we should bear alongside the normal cost. So if we estimate that slope value for the first activity, it would be something like this. So crash cost minus normal cost divided by normal time, which is this cell right here, minus crash time right here. Press enter. So what does this 10,000 now mean? These, let's call that this, the value of slope right here is in dollars, right? So these are dollars, right? So just like normal cost and crash cost. What does that 10,000 mean? 10,000 mean if we crash this activity A 1 period, which in this case is a week, we need to realize additional cost of $10,000 per period crashed. So let's suppose if right here the crash limit was 2, then this means if we crash this activity 2 times, then we have to realize $20,000 and so on and so forth. So that's what the slope value mean. And if you drag it down, you got all the slope value, or that is an incremental amount which you will realize when you crash a particular activity by some limit. Now, what is the second step in this algorithm? In second step, all we need to do is just copy these columns right here and paste them right here. And then we are supposed to come up with a third column. Let's call that third column crashing periods. So these columns, we are supposed to leave them empty because linear programming algorithm will identify these values. So for now, we are going to just highlight them. We'll, through a method, we'll tell linear programming algorithm to estimate these values given some constraints, such as the concept of linear programming. Now, there are three more cells which we need to generate. The next cell, the next column which we need to generate is what we call the actual duration or actual time or actual period of a particular activity in a project. So what's that? So if we consider the normal time or the normal duration of a particular activity in a project, so these are those values, right? Once the and we'll end up having actual duration. So what are we supposed to do here? We're supposed to put an equation right here. This cell is equal to this value, which is the normal duration without crashing, minus the crashing period that would identify your actual duration. For now, we don't have any crashing periods identified. We'll let simplex algorithm identify those. Let's drag it down. So we got actual duration right here without the consideration of crashing period, which is just the same as the ones identified right there. Now, the next column which we need to generate is what we call the earliest start and earliest finish. Now, what does those mean? For this concept, we need to consider the predecessor and successor relationship. So earliest start mean that when can an activity in a project start at its earliest? So for the first two activities, which I mentioned right here, there are no predecessors. So these activity can start at any time, right? So we'll consider their earliest starting time as 0. So they are starting at a timeline 0. Similarly, for activity B, that's 0. Now, what's the earliest finish? When can activity A and B, they can be finished at its earliest? So that is really simple. All we need to do is just add the actual duration right here with the earliest start value right there. And if we do that, just drag it down. So this column represents right here the earliest finishing time for a particular activity. Now, these are remaining. So how to go about those? These are the cells for the rest of the activities which have certain predecessors. So for activity C, predecessor is A, for D, it's a B, and so on and so forth. So how to go about that? If we talk about activity C, activity A and B could start without any predecessor. So that's why we took the time 0 and 0. So what about C? C can only start when A is completed. So when I say A is completed, then we need to consider its earliest finishing time of A. So I'm supposed to put it like this, equal to this cell right here. Why? Because C can only start when A is finished, and that's the earliest finishing time of A. And press enter. We're not supposed to put 2 here. So I'm not supposed to put 2 like this. I'm supposed to put up an equation. If I simply put a value 2 right there, simplex algorithm won't recognize that particular cell for its estimations. Now, moving on towards activity D. So what is the predecessor of activity D? It's B. So I'm supposed to click now this cell. So D can only start when B is completed. So B is the predecessor of B and D is the successor of B. So I'm going to select this cell right here. Similarly, for activity E, we got a predecessor, which is C. So I'm going to select this cell right here. And accordingly, for activity F, again, the predecessor is C. So I'm going to select this cell right here as well. Let's figure it out if we did that correctly. So for F, so if I put it like this, F2, so that's a C, that's fine. And for this one, F2, so that is again a C, that is fine. And about this one, so that is A, we are fine now. Now, what about these two activities, G and H? They got two predecessors. So for that to represent, we will use a function, which is a max function. And we'll apply max function on the two predecessor, which is D and E. So we'll locate the value of D and E, their earliest finishing time, select them like this, and just enter. So basically what we are telling Excel to select a maximum value between these. So it's 8 right there. Okay, now moving on towards the next one, which is H. So how to represent this one? So we are again to use the max function. And this time The predecessors are f and g. So we'll use max function on f and g, which is right here, and click enter. Now you see the values on this columns were changing when we were putting values right there. And this last value is important. This last value represents the minimum project completion time. That is the minimum project completion time without crashing. So this is your part first of this particular video. In part second, we'll apply the linear programming algorithm to find out that how to what extent we can crash this particular project, which has an initial minimum project duration time of about 15 weeks. So this is your part first, end of part first.